welcome to the lecture. Today we are going to discuss about group replacement theory. So far we discussed about replacement with the deteriorate by changing with money and without money. Here we are going to discuss about group replacement theory. It means replacement of items that fail suddenly or completely. Okay, for example, if you take the street lights, suddenly the street lights will fail due to some natural defects or due to some power or due to some other causes. Okay, then the government employees or then the government officials coming to the villages and they replace that street lights regularly. Okay, that is also one type of the group replacement. Similarly, coming to the industry, that group replacement will takes by considering the factors. Those factors we are going to discuss in this lecture. Okay, here there are certain items which do not deteriorate but fail completely after certain amount of use. Okay, here the item will fail without the time or without the period. Okay, suddenly they will fail after some usage. Okay, then these kinds of failures are analyzed by the method called as group replacement theory. Okay, in this group replacement theory, when it will be failed and how we are going to replace with the best cost. It means here we are going to optimize the replacement cost. Okay, based on the replacement cost only we are going to replace the items by a group manner, whether it may be failed or it may be live. Okay, hence large number of items are failing at their average life expectancy. This kind of items may not have maintenance cost as such, but they fail suddenly without any prior warning. Also, in case of sudden breakdowns, immediate replacement may not be available. Already we discussed earlier about that group replacement. It means we discussed about group replacement with an example of street lights. Okay, some days after the street light will fail. It means if we have the 10 poles we have, in that one light will be failed. Okay, so we are going to replace that bulb by some duration. Okay, it means some officials will came there and they will inspect that and they will replace. At the time of replacement, they didn't do that replacement at single item. They will replace total all 10 bulbs, 10 poles. Okay, they are going to affix new bulbs into that 10 poles by a concept of group replacement. Okay, here at the time of failure, it may not give any notice. Okay, suddenly it will be failed due to some certain reasons. It will fail, the bulb will fail. Those are without notice, the bulb will be failed. Those type of failures will came in this replacement. Okay, those times we are going to replace the items without deteriorate. Okay, we didn't consider any time period. Here we are considering only the money. Which one is the which year or which month we are going to replace with the optimal cost. Those are we considered here. Okay, next, here coming to the example, it should be noted that replacements individually involve periodic simultaneous replacements along with individual replacements in between. Okay, for example, fluorescent tubes, it means color lights we are using nowadays, then light bulbs, then electronic chips, then fuses, etc. Okay, if we take the gadgets or if we take any decorative items, any decorative electronic items, those are built with some circuits. Those circuits suddenly it may fail at any one place. We have to replace that individual circuit by the concept of group replacement. When we are replacing that item, we have to check the cost of the replacement. Similarly, we have to check the group replacement cost also. By comparing those two, we chose any one best. If it is individual cost is cheaper compared to the group replacement, we are going to the individual replacement. Otherwise, group replacement cost is best for that individual replacement. So simply we are going to take the group replacement for that items. Okay. Next, here first the concept why we are replacing the items in a group manner. Okay, here we are replacing the items in a group manner. It means sometimes randomly it will be failed. The items will be failed. Okay, those are we are going to replace this concept. Here a long period between group replacements results in increases in cost of individual replacements, while frequent group replacements are definitely costly. Okay, there lies the need to balance this and find an optimum replacement time for optimum cost of replacement. Just we discussed about this. It means when we are going to replace the items, we have to cross check the cost of the replacement by individual manner, at the same time group replacement. From that we are going to choose the optimal replacement policy, optimal replacement cost. Based on that optimal replacement cost only, we are going to replace the items by group replacement. Here the cost is the important factor. The cost is the factor. Okay. Next, coming to the example. Here I taken one example. From this example, I would like to explain this group replacement. First, here I taken the computer contains 10,000 resistors. When a resistor fails, it is replaced. The cost of replacing a resistor individually is ₹1 only. Okay, if all the resistors are replaced at the same time, the cost per resistor would be reduced to 35 paisa. Remind it. The percentage of surveying resistors, say that is S of t, at the end of month t, and the probability of failure P of t during the month t are as follows. Here they are given t, that is the time period, that is the month. 0, 1, 2, 3, 4, 5, 6 months they are given. Next, S of t, that is surveying resistors percentage they are given. At the 0th month 100, first month 97, second month 90, third month 70, fourth month 30, fifth month 15, and 6th month 0. Next, coming to the P of t. Here there is no probability at the 0th month. It means 100 is there. So next 0.03, 0.07, 0.20, 0.40, 0.15, 0.14. Okay. I think it is also not 0.14. It is also 0.5. Okay, I would like to take this is also 0.5. It is not 0.14. 0.15. Okay. Then what is the optimal replacement plan? We have to calculate the optimal replacement plan. Okay. Here what they are given? They are given 1000 resistors. They are given 1000 resistors, and the cost of replacement is they given individually and group. If suppose we replace individually, ₹1. For each resistor, the cost is ₹1 for individual replacement. If suppose we replace grouply, the cost is 35 paisa. Okay, it means when we are going to purchase a bulk resistors, we will get at 35 paisa amount. If we purchase only one resistor, means it will take ₹1. Okay, if suppose when we are met the repairs or when we met the electronic shops, they will ask how many pieces you require. If we ask very less amount of pieces, they told very high price. If we ask bulk number of products, they will reduce the price. Like that also, here also one resistor cost is only ₹1. And if we take the group of resistors, it means we collect many resistors. That means 10,000 resistors means they will give 35 paisa. Okay, now coming to the failure. Here they are given the percentage of surveying resistors they are given. First, at the 0th month 100 resistors were taken. Okay, then the second month those are 97%. It means 3% are failure. Then second month 90% were taken. Third month 70%. Fourth month 30%. Fifth month 15%. Sixth month 0. Next, probability they are given. Probability means which probability they are given? The probability of failure they are given. At first month, at 0th month, initially we are installing. At the time there is no failure. So 100 are in live. So there is no probability. Next, coming to this 0.03. Here one important thing is there. Some examples they didn't give this probability. We have to calculate the probability. Here if suppose we are going to calculate the probability means we are using the surviving of resistors we have to take, surviving factor we have to take. From that surviving factor we are going to take the difference between two surviving factors. From that we are going to calculate the probability factor. Here I would like to calculate this 0.03 from this S of t. Here for simply we are taken. Then at 0th month we have 100 resistors, and second month we have, it means first month we have 97. This is a percentage, that's why I am taken 100. That is equal to 3 by 100 is equal to 0.3. They are already calculated and they given the probability 0.03. Next, coming to this second one, what is the probability? 97 minus 90 by 100 from this 0.07. Likewise, we have to calculate for probability of the months for a failure. If they didn't give this, okay, if they given means they no need to calculate this. Already they are given means we are going to directly find the optimum replacement plan. Okay, now coming to the solution. Here we have to assume Ni. Ni means that the number of resistors replaced at the end of the month. Here how many number of resistors we have? Totally N0, that is N0 I would like to take. N0 is equal to number of resistors in the beginning. In the beginning, the problem itself they are given. Here the beginning they are given 10,000 resistors. So same quantity I taken here, 10,000 resistors. Okay. Here already given, that's why I didn't take the resistors there. Next, coming to the N1. N1 means number of resistors being replaced by the end of first month. Okay, here we are going to replace the resistors at the end of first month. It means how many number of failures we have. We have to calculate how many number of resistors are failed at the end of the first month. First we have to calculate. Based on that we are going to replace that resistors in an individual manner. Okay, here at first month they are given. What they are given at first month? They are given probability factor, failure probability factor is 0.03. At total how many number of resistors are there? 10,000. That is N0 into P1. At first month we have to take the formula is N0 P1. Here what is the N0? N0 means already defined N number of resistors in the beginning. It is the initial count 10,000. Then the P1 means at the first month probability. What is the first month probability? Here the first month probabilities they are given 0.03. Okay, that is equal to 10,000 into 0.03. That is equal to 30. Okay, that is equal to 30. Next, coming to the second month. What is the second month? The second month number of resistors N2 I would like to take. Here for this second month I would like to write the formula is from initial month onwards we have to take the failure, that is N0 P2 plus N1 P1. That is for second month. It is initially count and first month resistors count and second month that is the probability factor of second month ending, the probability factor of first month ending. Okay, here N0. What is the N0? N0 already we have initially, that is 10,000. Okay, 10,000 plus 10,000 into what is the P2 value? P2 is we have here the P2, P of 2, T is the month, P of 2 means second month, 0.07 plus what is the N1 value? N1 here already we calculated N1. N1 we calculated from initial month and first month the end failure. Okay, that is 30. 10,000 into 0.03, that is 300, not 30. 300, that is 300 into 0. What is the failure here? Here the failure is 0.03. This is 0.03. This is not 0.30, 0.03. From this we get 709. From this we obtained 709. And similarly, coming to the third month. Here we are going to find number of resistors in the third month. Here how many number of registers are failed in the third month we have to calculate. At third month means similarly we are taking N0 P3 plus N1 P2 plus N2 P1. Okay, here what is the N0 value? N0, what is N0? 10,000. 10,000 into P3. What is the P3? Here the probability factor P3 is 0.20. 0.20 plus N1. What is the N1 value? N1 here we get 300. 300 into P2. P2 is 0.07. 0.07 plus N2. What is the N2 value? N2 here we get 709. 709 into and what is the P1 value? P1 is 0.03. From this we get 2042. Okay, next coming to the N4. Here we are going to calculate the N4. N4 means same N0 P4, N1 P3, N2 P2, N3 P1. Okay, here N4 means here we have one logic to remember for this formula. Here if suppose we have the 4 months, the probability also we have to take the 4th month and we are going to decrease the probability, and here the probability value is we are taken the and coming to the N value, that is the number of registers we are taken from the initial stage. Here we are increasing the number of registers and we are decreasing the probability month like that. N0 P4, N1 P3, N2 P2, N3 P1. Okay. Here N0, what is the N0 value? N0 is 10,000 into P4. What is the probability factor? P4 is 0.40. 0.40 plus N1 P3. What is the N1 value? N1 is 300 into P3. What is the P3 value? P3 is this one, 0.20. Okay. Next, N2 P2. What is the N2 value? Here already we calculated. N2 is 709. 709 into P2. What is the P2 value? 0.07 plus N3 P1. What is the N3 value? N3 value 2042 into P1 0.03. Okay. From this we get 4171. Similarly, we are going to find the N5. N5 also N0 P5, N1 P4, N2 P3, N3 P2, N4 P1. Here what is the N0 value? N0 is 10,000 into P5. Probability factor is 0.15. This is also 0.15. Okay, 0.15 plus N1 P4. What is the N1 value? N1 is, here we get 300 into P4 0.40 plus N2 P3. What is the N2 value? N2 is 709. 709. P3 value is 0.20 into 0.20 plus N3 P2. What is the N3 value? 2042 into P3 is P2 is 0.07 plus N4. What is N4 value? N4 here 4171 into P1 0.03. Like that we are going to calculate N6 also. Okay, after calculating these all values from the values of N1 to N6, it can be seen that the expected number of resistors failing each month increases up to the 4th month and then starts decreasing and later increases in the 6 months. Thus the value of Ni will oscillate until then system. Okay, here the cost values, you can see here these values are increased up to fourth year. Then after the fourth year, after the fourth month, it will be decreased. Okay, here we are going to calculate the expected life for each resistor. Okay, from this we didn't get the each life of the resistor. Here the life will be reduced and the life will be increased. Okay, now from this we are going to calculate the life of the resistor by taking the formula. Expected life is equal to sigma I is equal to 1 to 6 xi p of xi. Here the xi means the month, failure month we have taken. Then the p of xi means probability period we have taken. Here the xi means we have taken 1, 2, 3, 4. This is the xi value. 0, 1, 2, 3, 4, 5, 6. Those are the xi values. And PTV means probability factor. P of xi means. Here we can take x in place of x we can take t also. Okay, sometimes we are going to take t or it may be x. Okay, here I would like to expand this equation first, then I am going to substitute the value. Here suppose if we expand this, how many number of months are there? I is equal to 1 to 6 months are there. Okay, at the starting month we didn't consider here at 0th month, because 0 if we multiply with 0 for anything, we ultimately we get the 0 value. That's the reason I won't consider the 0 here. Just I taken from the first month itself. First month means x1 p1 plus x2 p2 plus x3 p3 plus x4 p4 plus x5 p5 plus x6 p6. Here what is the x value? The month, duration, that is also called as t. And what is the p value? P1 means probability period. Here we have how many number of months are there? 6 months. So first month we are going to take 1 x1, 1 I am taking, and p1. What is the probability period of p1? In our table we have the point p1 is 0.03. Next, coming to the second month 0.07 is the probability factor. Next, third month 0.20, fourth month 0.40, fifth month 0.15, sixth month 0.15. From where we get these values? These values are we taken from the tabular column. Okay, that is here. These are the probability factors we are taken. Okay, these values we are taken there. Here, the expected life is 4.02 months. Each resistor, the expected life is 4.02 months. After that, we are going to calculate the average number of failures per month. Every month we have the difference between the probability of failure. So now we are going to calculate the average of that failure. Okay, by taking the formula is average of failure is equal to n by mean age. This is the formula. N by mean age. N means number of resistors at initial stage. Okay, how many number of resistors we have? 10,000 number of resistors we have at initial stage. Then mean age. Here we calculated the mean age. Mean age means expected life of the resistor or expected life of the product. That is called as the mean age. The expected life we calculated, that is also called as mean age, is 4.02. From this we get 2488. What is this? Average number of failures per month. Every month 2488 resistors are failed. Okay. Now, hence the total cost of individual replacement and the cost of rupees per resistor will be, if we take individual replacement, here per month we are going to replace 2488 resistors. Initially they are given individual replacement cost for resistor is 1 rupee. If suppose we are going to replace 2488 resistors, it will 1 rupee. So the cost of the individual replacement is 2488. Okay, now we are going to check the group replacement. Now we are going to calculate the group replacement cost. In our problem they are given group replacement cost is 35 paisa. According to that we are going to calculate the group replacement value. Okay, by taking the table I am going to calculate group replacement cost here. Okay, here I have taken end of month, first month, second month, third month, fourth month, fifth month and sixth month. Next here second column I have taken total cost of group replacement with cost with rupees. Next finally I have taken average cost per month. Okay, average cost per month I have taken. Next coming to the first one, here the total cost of group replacement. Here the total cost of group replacement. How we get this? It means at initial stage, at initially we have how many number of resistors we have? 10,000. 10,000 resistors we have. Okay. And what is the cost of group replacement? If suppose if we going to replace 10,000 resistors means the price is 0.35. Okay. Same. At initially how many number of resistors are paid? Already we calculated. Here we calculated. At N1 number of resistors being replaced by the end of the first month. At first month 300 resistors are paid. We are going to replace 300 resistors. Okay, here 300. And what is the cost of individual replacement? Into 1. Okay, from this we are going to get the group replacement cost. Here we are going to get the summation of these two. 10,000 into 0.35 and 300 into 1, that is 3,800. That is 3,800. So the cost average is 3,800. The total cost is one at first month. So the cost average is 3,800 by 1 equal to 3,800. Next coming to the second year. Second month, not year, second month. Here the second month. Coming to the second month, it is a constant. Then what is the constant? Here 10,000 into 35 is the constant for all months. Plus next here we are coming to the second month. First we have to take the values of the second month. By cumulative of the first month and second month we have to take here. At first month how many number of resistors are paid? 300. And second month, coming to the second month, how many number of resistors are paid? Here we calculated 709. Okay, 709 into 1. Okay, from this we get 6,551. Okay, are you understood this? 300 plus 709. These are the values of the end first month and second month of resistors. Next, these are the group replacement of resistors. Okay, here 6,551. From this we are going to calculate the average. Sorry, it is not 6,000, 4,509. Okay, we are going to take the average. How many number of months for this? 2 months. So we are going to take the 2 months average. 4,509 by 2, that is equal to, we get 2,254.50. The same coming to the third month. Same here. First month failure is 300. Second month failure is 709. Third month failure is 2,042. And the cost of the replacement, it is a individual manner we are going to replace here. That is 1. Then suppose we coming to the group replacement, total 10,000 is there. So 0.35 is there. Price cost. So from this 6,551 rupees. Okay, we are going to take the average. Means by 3 I am taken. So from this 2,183.66. Similarly, coming to the fourth month. First month failure 300. End of second month 709. End of third month 2,042. End of fourth month 4,171 into 1 and 10,000.35. Okay. These two are the separate terms. Next, same 300, 709, 242, 2042, 4171, 2030 into 1. Same 10,000.35, 12,752. Here 1072 by 4 is equal to, we get the average cost per month 2,680. Here by 5 means we get average cost per month 2,550. Here 300, 709, 242 4171 230, I mean 2030, 2590 into 1. It is for individual replacement. And coming to the group replacement, the value is 10,000 into 0.35. From this we get 15,442. And we are going to take 6 means we get this. We obtain the average cost per month. Okay. Here, since the average cost at third month, we have the least value, that is 2183.66. It is so it will be effective when all resistors are replaced, effective every 3 months. Okay, every 3 months we are going to replace the resistors with the cost of 2183 rupees 0.66. It is for group replacement. If we individually replace this, means we get more than that. That is, here we obtain at third month 2042 for individual replacement itself. Here for group replacement we have 2183.66. Okay. Here the price will be reduced and up to the third month. Then the third month onward the price will be increased. So here the minimum value is there. So we are going to take the third month is the replacement month. Here we did the group replacement for this month. Okay. Thank you. Okay. Thank you.